In this section, we will be solving polynomial inequalities. If you look closely at the left-hand side, we are looking for the values of x that, when substituted into the two different factors, gives us a product that is less than or equal to 0. We'll be looking for those intervals that result in a product that is negative or 0. Here are the steps that will be helpful to us in solving these polynomial inequalities. Our first step is to set to 0 and then completely factor. Set all of these factors equal to 0. We will term these zeros as critical values. They are the values that, when substituted into the polynomial inequality, gives us 0. We may or may not be including these zeros or critical values. It depends on the inequality. Next, mark these values on a number line, breaking up your number line into intervals. Our next step is to work with the factor and its 0 and determine to the left or right of that 0 what sign we would have if we substituted in values that are smaller or larger than that 0. This is done for all of the factors. Last, we check the sign of the products of these signs and see what intervals on the number line will satisfy the inequality. We go back to the original problem, completely factoring the polynomial. We find that there are 4 different factors. Therefore, there are 4 zeros or critical values. We will mark 4, -4, 1, and -1 off on the number line. When this polynomial is factored, it is made up of 4 factors. We need the product of these 4 factors to be less than or equal to 0. At this point, we are not so much concerned with actual numbers, but rather signs. We need the product of these 4 factors to be negative or 0. The very bottom of the slide is the number line with the 4 critical values marked off. Since our inequality is less than or equal to 0, the zeros or critical values are included. That is the reason for the red dots being solid. The next step is to divide the number line into intervals about these critical values. Notice how I have drawn vertical lines up from the critical values. This breaks the number line up into 5 intervals. The horizontal lines are drawn in across from the 4 individual factors. This is more for just structure and organization to the process that we're about to go through. What is determined at this point is the sign of values to the left or right of a critical value. Let's start with the first or top factor. The critical point, or 0, to x minus 4 is 4. At 4, this factor is 0. If we were to substitute any value less than 4 into x minus 4, we would get a negative. Notice the negative signs drawn in to the left of 4. Any value greater than 4 substituted into x minus 4 would give us a positive. Notice the positive signs to the right of 4. Next factor, the 0 to x plus 4 is -4. Any value less than -4 substituted into x plus 4 gives us a negative. To the right of -4 we get a positive. This is done for each factor. Now keep in mind what we're trying to solve here. We're trying to solve a polynomial inequality. The product of these 4 factors needs to be less than or equal to 0. Our next step needs to be us looking at the products of these signs in each of the 5 intervals. Here's the number line broken up into the 5 intervals. For the first interval, negative times a negative times a negative times a negative will give us a positive. Notice the plus signs on the top of the number line to show this product. For the second interval, negative times positive times negative is a negative. And notice the negative signs on top of the number line to show this product. For the third interval, negative times a positive times a negative times a positive equals a positive. Notice the plus signs on the top of the number line to show this product. And for the fourth interval, we have negative times positive times positive times positive, which gives us a negative. And notice the negative signs on the top of the number line to show this product. For the fifth interval, positive times positive times positive times positive equals a positive. And notice the plus signs on the top of the number line to show this product. Our polynomial inequality needs to be less than or equal to 0. We need the product to be negative, and we need to be including these critical values. Our solution set includes all areas on the number line that result in negative products. Hopefully this has been helpful. Thank you for listening.